Now we are going to discuss about thermosets, right? The thermosetting plastic structures and polymer chain that cross length is shown here. This making method also shown here. The extensive cross linking formed by covalent bonds, right? And the bond prevents chains moving relative to each other. Okay, the thermoplastics are usually either to mold into complex shapes, but in thermosetting plastics offer more the following properties. For example, it will be high thermal stability, and it has the high rigidity, and it has high dimensional stability, and resistance to creep and deformation under load, and it has lightweight material compared with other materials, and it has the high electrical and thermal insulating properties. Okay, these are the very important properties. The types of thermosetting plastics. Okay, we have three types. First one is epoxy, polymer, and polyharmacycle. Okay, and that epoxy structure is shown here. Polymer and poly homocycles are also shown here. The epoxy is a polymer that contain an epoxide group in its chemical structure. That structure also shown here. Characteristics of epoxy. It has the better moisture resistance, and it has the low shrinkage, and it has the good adhesion with reinforcement. Polyester. Next, we're going to discuss polyester. Polyester is a condensation reaction between the glycol and an unsaturated diabetic acid results in polyester. Okay, this contains a dot bond C equal to C between its carbon atom. For example, polyethylene terephthalate. It have some characteristics. It will be very cheap, and the resistance of variety of chemicals, and adequate moisture resistance. Okay, these are the characteristics of polyester. Thermosetting plastic applications also given here. First. It has using in electrical voltage, and to make some fibers and cooling items, and cook easy to make cookware, right? And additives. These are the various applications of thermosetting plastics. Thermoplastics polymer thermoplastic polymer individual molecules are linear in structure with no chemical linking between them. That is shown in here, and also are held in place by weak secondary bonds such as van der Waal bonds, any hydrogen. It is intermolecular force. Some thermoplastics normally don't crystallize. They are termed as amorphous. Plastics are also useful at the temperatures below the teeth. That is shown here. In the thermoplastics, that non-cross linking is making heat and is getting the scarf shapes. The polymer chain easily broken by heating. Polymer can be modeled into new shapes. There has no cross link between chains and weak additive force between chain broken by warming, and can easy to change shape and it can be too easy remodeled, and weak force reform in new shape when cold.